Hi, Pradeep. Good
Good
morning.
morning,
Hi,
Pradeep.
good morning, Dr. Deepak.
How
How
are
are you?
you?
Good, Pradeep.
Long
What's
time.
happening?
See,
What's
Yeah.
happening from your end?
yes, we are again getting into lockdown from today.
Oh,
Oh,
okay.
but is it so serious now there?
Yes, because now the cases have increased a lot, um,
Okay.
and so they have asked for a strict lockdown until January 19th. So we are on lockdown from today. So
Okay. Okay.
everything is closed except supermarket. So
Oh, oh.
because people here were very casual initially,
Okay.
uh,
Okay.
so
But since it
now
is
they
since it is more or less like a festive time, so it
yes,
will not hamper
Yeah.
much.
yeah, but and at the same time it's a winter time, right? So
Yeah.
so the cases will increase more generally.
Definitely. Yes. Yes. Yes.
So the better thing is close until end of next month, and we are not allowed to travel outside the country until
Okay.
Oh,
mid March.
Oh,
So
so you will be
until
tied there
mid-March.
only, March. Okay.
yes.
Hmm.
So
That
how
is
are you all?
difficult. How about
Yeah, we are all doing good. Yeah.
logistics?
Good.
Everything else will be very difficult, right?
Yeah, means if you have car, then it's fine. But otherwise the train, buses are all running, but there won't be any people on the road.
Oh.
So,
Okay. Good.
so how are you all? How is Bangalore?
Yeah.
Uh,
Yeah. Bangalore is as usual little chill compared to last year.
okay,
COVID position is, I think, stabilizing somewhat, not increasing. That's what I think, getting reduced. That's what I can say.
okay.
Hopefully, we will not, initiate the second cow. So if it diminish, it is better. Expecting
No,
that only.
yeah, I think even this will start, right? Vaccination will start soon.
Yeah, yeah,
Uh,
yeah.
But that will take some time, I guess, since they will have several
yeah,
phases
yeah.
also.
It will
How
take
they will,
until end of next year almost to
Yeah, yeah. To
vaccinate
come to the
everyone.
common people. Yeah.
Yes, exactly.
so any new sessions or new courses you are doing right now?
No, I'm taking care of my family first now.
But
Okay.
anything online? Are you teaching now?
Yeah, I was teaching at Great Lakes.
Yeah. Now? No.
No, I have kept quiet for some time. I also need. I will start, but I need also some time for myself. So
Yeah. So best
because
part is we can take your assistance during this time.
Till the time. Till take up the next
always,
assignment. Yeah.
always
Yeah.
welcome.
Nice.
Thank you very much for all the support so far.
Yeah, yeah. Because of your support, no, with the no, you are
And
there. I have started just like that.
no, I'm really
So some,
sorry.
no,
Two
nothing like
people
that.
have
No, no, no. That
disappointed.
is fine. Only thing
Actually, they
is,
are really good.
yeah, yeah, fine. Yeah, we will. He also replied that he can handle session in the month of January. I said, okay, no problem. Nothing
Yeah.
wrong in that. See, everybody have somehow the other difficulties. We can't say that when we want it, at least they have accepted. No, that boost us little moral. Then we started working with a good speed.
Yes,
Good, no?
exactly.
Yeah, yeah.
Good. Thanks.
So another 1 minute to go. So
Yeah,
what
we
I'll
will
do is
start.
I'll just introduce you. Okay,
Sure.
and
Thank you.
before that, HOD ma'am will be able to address the gathering, and then
Sure.
we'll go ahead with your keynote speech here.
Yeah,
Yeah, I
sure.
think
Thank you. Thanks.
we need to let the people in. It's
Yeah,
better, no? One
yeah.
minute, so
Muzammil
it is better. Muzammil?
Yes, ma'am. I'm letting them
Yeah,
in.
yeah, letting them in.
So you can hear me properly, right? The
Yes,
Yeah,
audio
yes,
is
no
hearing.
issues. No issues. So you are studying too much. So everywhere books are there on your background.
no, just to show others that I'm studying.
Yeah, good, good,
The books are there. I keep buying,
good.
but how much I study, I don't know.
Okay, good, good.
That's
Right.
We'll just wait for another 1 minute or so that others join.
yeah, sure.
We are live, ma'am.
Yeah, right, ma.
Ah.
What about the banner? Yeah, you put that banner for some time, Muzammil, till the audience let in.
So once I start, I pause the audio video
Oh.
from my end, because otherwise the bandwidth will be low. Is it fine? Yeah.
No, your video, if it is on better, we all will close it. So let yours is
Okay.
on.
Okay. Fine.
Fine, na? Fine for your side?
Yeah. Sure. Sure.
Yeah, yeah.
So it's 11 o'clock there, right?
We'll start now.
Yes.
Good morning, one and all present here, Mr. Srinivas, Pradeep, my dear faculty members, students, and all the faculty members from other places. I'm Dr. Hemalata, Professor and Head of the Department, inviting you to the great event today. We have with us Mr. Srinivas Pradeep, data scientist from Netherlands. He's going to share us about demystifying artificial intelligence in the data world. And it's my immense pleasure to welcome you all for this gathering. And this is the second day of our artificial intelligence conclave. We have lined up series of expert talk to update ourselves from the industry, and also hands-on session from the industry experts to the management graduates. So I, on behalf of Department of Management Studies, Dananda Sagar College of Engineering, I welcome you all to this second day event. I over to Dr. Deepak for introduction about our guest, and then it will be handing over to Mr. Pradeep for further. Thank you.
Thank you, ma'am. Thank you, ma'am. So, good morning, everyone. So, before we go ahead, just a quick reminder to all the participants to not unmute the audio or share video or personal screens during the sessions. And I would request the audience to ask the questions, if any, at the end of the keynote address by our respected speaker. Now, today we'll be shifting gears a little and deconstructing the ecosystem of big data analytics with AI with our today's keynote speaker, Mr. Srinivas Pradeep, data scientist. And Mr. Pradeep is the data science practitioner with experience in AI and machine learning. He has worked with Mercedes-Benz, Shell company, and other companies. And he is currently based out of Netherlands. And I would like to say also that Mr. Pradeep has been very supportive to the department from the time we started business analytics specialization. He has always been an inspiration in all our endeavors. So without further ado, I request Mr. Pradeep Srinivas to address the gathering.
Sure. Thank you, Dr. Deepak, and thank you, Dr. Emlata, and the management team and the faculty members. So it's really immense pleasure for me to present the new topic in front of all of you. I would really thank everyone for giving me this opportunity to present. And Dr. Deepak and Dr. Himlata has been really inspirational in terms of supporting these initiatives, and I would really like to thank them again, and also the faculty members. So with this, I will like to start my presentation. So before going to the presentation, I would like to give a brief about what actually I'm going to talk about today. So don't go by the title. It's demystifying AI in the big data world. So we all talk about AI, we all talk about big data, but we really sometimes miss out the basic conceptual things which are actually covering those AI. We always talk about AI is used in this, AI is used in that, but we never think about that what all the building blocks of AI and what actually constructs. So basic concept things which can actually really help in building up the AI block. So today my session will be focused on introducing you all. Maybe you would have already gone through many of these things, and your professors have already taken you through all these terminologies and things, but it's always a good refresher to understand that what actually constructs and helps in building the artificial intelligence. My talk will be totally focused on that, with introducing what is data science, what is machine learning, what is deep learning, and how all this constructs into an AI, and what are the different examples which we see in our day-to-day life, which can be actually called an AI and which is actually an AI. But still, to be very honest, so far there is no system or nothing has been built which is called an artificial intelligence, because as of today, there are no system which has been built which can think artificially or think on its own. We all build things based on past historical data and then predict, but we are still building on things where the machine can learn on its own and start intelligently answering the questions. So with this, I would like to start my presentation. um, uh, Dr. Deepak, can you please
Yeah,
allow me to share the screen?
1 minute.
So you can share the screen.
Yeah, sure.
I've given you the
Uh,
access.
it still stays that host disable participant screen sharing.
Can you check it now, sir?
Yeah, sure. Yeah, sure. Thank you. Yes, I can do that. Dr. Deepak, can you please see my screen?
Yeah, we can see it. Yeah.
Is it clear now? Is it visible to you?
Yeah, it is visible. Yeah.
Okay. So let me start so this is the agenda which I'm going to talk about today, like what is data science, what are the different process of data science, what is AI, what and how AI and ML are related, because still the concept is not clear in many places where people still mix up things like how is AI and ML are related, what is machine learning, different types of machine learning, when to use AI and ML, because we started since it's the buzzword which is going around across the world. We try to use in each and every stage, but actually we should know when to use AI and ML. What are the pros and cons of using this? Because sometimes even a simple Excel thing and a simple analysis can solve your problem rather than using an highly complex artificial intelligence or machine learning kind of a problem. And I would also like to talk about what are the recent AI developments where people are applying AI and how the world is changing, and how these are a few examples like how artificial intelligence is used in the creative industry, what are the building blocks of AI, how the spectrum of data science looks like. Finally, I would like to also talk about what are the common tools and techniques which are currently used in the industry, and what all actually the skills required to solve these problems. So let me start. With the first line, that data science is not a rocket science. It's quite a simple thing, but rather it has been projected as a very complex stuff, but it's a very simple thing which anybody can learn, and even artificial intelligence or machine learning or deep learning can be learned by anyone. So this is a very simple thing, but just we require a little bit of skill enhancement and few knowledge to get to this stage. So typically, what is actually a data science? This you would have already gone through it, but I would like to reiterate this again. This is nothing but it's a scientific method or process or algorithms which and the systems to extract knowledge and insight from an unstructured and a structured data. So please hold on for a minute. What you mean by structured and unstructured data? Maybe you know already, but I would like to explain further in detail what actually you mean by structured data and unstructured data. On your right hand side, this is the famous Venn diagram which actually talks about how the data science is evolved and what all the elements of that. If you see that it's comprises of computer science, data processing, domain expert, statistical research, and mathematics, and of course machine learning. So one need not have to be competent in all of them, but at least a basics understanding of machine learning or computer science or statistical methods can really help you in building the concept of the data science. So like mentioned in the previous slide, like what do you mean by structured and unstructured data? Like the structured data can be which can be displayed in rows and columns and the relational database, and the unstructured is which cannot be displayed in rows and columns and or any databases. And it requires structured data requires less storage, and unstructured requires more storage. And these things, why I'm talking about this unstructured, because these are the building blocks of your AI in future, where you going to build your machine learning or deep learning models, which or doing any data science related work. It's basically to understand that how this data, what kind of data we have, and how we are going to solve those problems. And the structured data is very easy to manage, and the unstructured data is like very difficult to manage, and it requires a lot of legacy solutions. So come this is something which I would like to talk about, like how the day looks like for a data scientist, because we heard much about data scientist, lead data scientist, senior data scientist, these words, right? But actually what they do on the day-to-day basis, right? So it starts with a nice coffee in the morning at office. Now it's a COVID, so we are all working from home, so nice coffee at home. And then it starts with understanding the business problem. So you interact with your peers, you interact with your managers to understand what are the problems which we are going to solve. So once you understand the problem, then we go to data acquisitions, where we talk about, okay, we understood the problem, so what kind of where is actually the data is located, what kind of data, where actually it is, whether it's in the form of database, whether it's in the form of APIs, whether it's in the form of an online repositories or a web server. So once you understand the problem, then you go for data acquisition, and then you acquire the data. So but the data which you acquire is not always clean, so the real life data is always messy. So you go for the data preparation, where you talk about data cleaning, transformation. So once that is done, your data is ready for doing an exploratory data analysis, where you do visualize the data using different tools, like you have SPSS, R, Python. So these softwares or tools which you can use to do an visualization. And then after all these things, sometimes people stop at the exploratory data analysis because that's what is required. And once that is done, sometimes you need an advanced modeling, data modeling. So where you go for building a different machine learning or a statistical model using decision tree, KNN, etc. So once that is done, then you go for visualization and communication, where you go and communicate with the people. So there are different softwares like Tableau, Power BI, ClickView, and other softwares which can actually help you in further communicating to the management, because management don't understand the complex mathematical algorithms behind it, but what they understand is more of a visualization. So once all this is done, so it doesn't end here, right? Because the end user has to use it, whatever we have built it. So whatever the data scientist has built it, so they have to use. So once this is done, so then the final stage comes is deployment. And what we mean by deployment is like whatever the model you have built, you have to give a nice user interface to that, so that the user can easily use it without seeing actually your mathematical algorithms or visualization running behind. So then finally, this is the last step of a data scientist, which he performs. Like it starts with day and does all this process, and then finally ends with an um, uh, deployment phase. So in quick way, like it talks about the goals, what are the goals, what is the acquire, how do you acquire the data, how do you build it, how do you, what all the things which is required to deliver it, and how do you optimize your model finally. This optimization is where the deployment phase comes into the picture, where you finally take your model, put it in. Now we are talking about deployment. What you mean by deployment is how the end user is going to consume it in terms of an user interface. For example, if you go to any website and try to enter your information, and then finally you get your results, right? So this is the user interface which you are going to build. And now we have all the you might have heard about cloud. So there are cloud infrastructure, like Azure, Microsoft's product, Google Cloud, or Amazon's web service. These are the places where actually you can build your own model. You have everything inside that, and then you go and deploy it in there itself, giving a nice user interface to the end user. So now people are, since it's a big data world, people are all moving towards cloud, because there's a huge amount of data and you require a lot of servers to manage it. So in general, this is the data science process. So now I would like to talk about what are the common terminologies and the spectrum of data science. And uh, we talk about different things, like we talk about reporting. In the industry, we generally talk about all these five things which I have displayed in the graph, like reporting, business intelligence, predictive analytics, machine learning, and artificial intelligence. If you see, everything in the industry is covered under within this, but it's all depends on your x-axis. If you can see the business value, what it how much business value it generates, and on your y-axis, if you can see the complexity, what is the complexity of the problem, right? If it's a low business value and low complexity, then actually you go for an reporting. This is very important because when you go and go to the industry and start solving any problem which your management gives, first of all you have to ask what is the business value it's going to generate and what is the complexity of that. Then use this graph to, you can place it like what you can possibly do. If the business value is high and if the complexity is also high, of course there is something which we are going to build is an artificial AI product, which is nothing but a chatbots or robots. But if it's something in the medium, then you go for a predictive analytics or a machine learning kind of stuff using your neural networks or all basic statistical algorithm which is already in the picture. So it starts with reporting and it finally, sometimes it's a end to end, right? You start with the reporting and then finally you end up in building a chatbot or a robot which actually covers all your predictive analytics, business intelligence, and machine learning. So this is generally the spectrum of data science where it covers everything which is used in currently in the industry. So we talked about predictive modeling and machine learning. This is always, these are the two terms which is always a little confusing, like how do you differ from a predictive modeling to a machine learning model. So predictive modeling is used to perform more granular prediction, like who are the customer who will like to buy a product in next month, and then act accordingly. So you act based on whatever you get from your data, historical data. Whereas machine learning is like where it can learn from data without any rule based programming. Here we are not defining any rules. It automatically understand from those patterns, like what actually the data is, what all the patterns we are going to get from those data. So this is generally a differentiation between a predictive modeling and a machine learning. So we all talked about artificial intelligence, machine learning, predictive modeling, business intelligence, and all. But there is a difference between human versus an artificial intelligence. So why you need an AI system when compared to you already have a human, right? Which can think almost like much more faster than a system or a machine. So in general, the human intelligence is like to make an informed decisions, communicate with people, identify patterns in data, remember what people have said, adopt to new situations. That's human intelligence is all about. But if you see artificial intelligence, it's actually communicate with people in more natural language like a human. It provides more accurate results because you don't have to store everything in your mind to say that okay, what will be the forecast for this in particular in 2025, right? You build a machine, you train it, and automatically this machine will automatically tell you everything and communicate to you in a more natural language and in any environment, and it can adapt to any environment, and it learns from repetitive tasks, so you don't have to human. So that's one of the reason why people are building AI systems compared to human, because we can focus on much more other work when compared to doing a repetitive task again and again. So if you have a AI system which can actually talk and behave like a human, then there is no need of a human as such. But of course you have to be there to see that how it's performing, how can you improve things. So that's generally what I like to cover is like we talk about AI which is actually created by human, but we need to really understand what's actually the difference between a human intelligence and an artificial intelligence. So now we spoke about the basics of like how business intelligence reporting everything looks like, but we also like to know what actually a machine learning, what is a deep learning, and artificial intelligence. These terms are very frequently used in the industry, and people sometimes say deep learning is machine learning, sometimes people say machine learning and deep learning is an artificial intelligence. So I will just like to talk about like what's actually the difference between these three, right? So artificial intelligence is an intelligent machine that work and react like humans. That what I explained in before, that it's almost work like we are building it. So almost it has to talk and behave and respond like a human. So what all the intelligent machine currently we have it in the, we are already using it, and we are already seeing that these things are already there uh, on the road and along with you. For example, if you see identifying the objects, we talk about self-driving car. It automatically identifies the objects on the road like buildings, car, human, everything. So these are, we call it as an intelligent machine because it doesn't need any human intervention as such. Now let's move to see speech recognition from Siri or Alexa. Right, this is all an AI systems which is built at the background, and whatever you ask, it's response. So the same concept of like it's an intelligent machine with that work and react like humans. That's what it's currently happening in the. So it can be represented in a very nice diagram, visualization, where it talks about the AI, artificial intelligence is the bigger spectrum, and this machine learning and deep learning are part of the artificial intelligence itself. So it's not like something, these three are completely different. Rather, the machine learning and deep learning are actually makes this artificial intelligence as a one whole system. So so if you see deep learning, we talk about machine things like a human brain using your artificial neural network. And what machine learning is like, it's actually learn things without being programmed or any rule based program. And when these two things combine, actually it comes and become an artificial intelligence system which can think and act like a human being. So let me go to the another example. Like this, you might be already knowing that how Amazon Echo works. When you ask something, it actually responds to you with, "Oh, what is that?" But what actually goes inside is nothing but whenever the user requests for any information, these commands are converted from text to speech to text, and these are all converted into a binary format. And once that is done, then the Amazon Alexa, what is in between, it process everything, and then it converts this text into speech and send it back to Amazon Echo. So if you see, this is how the artificial intelligence system works in a real world, where we already have these systems, but we can't call it as an artificial intelligence system yet, because still we are feeding our own data to learn from this, and then again it actually responds back. So ideally, when the day will come when you don't have to feed anything and the system thinks on its own and then finally delivers, that's the real artificial intelligence system will be. Another thing is like Amazon Go. You might be knowing. So you don't have to really, on your right hand side, you see that how people are standing in the queue for long, holding all the things together in the basket and waiting for their turn to come and pay. And especially in terms of COVID, it's difficult to stand like this and for a longer period of time. So Amazon Go is very nice, where you have an app where you go, you don't need any lines or checkout. On your left hand side, if you see, it's just you go and then pick up whatever the things you want, and then at the end you just check out with your mobile app and then go out. That's it. So you don't have to wait in the queue for a longer period of time to really get your things done. So I will share this link with later. You can see this YouTube video which actually nicely presented by Amazon in terms of how AI is evolving. Another thing is the driverless car, which I already spoke about, like how Google is coming up with their self-driving car to identify things on its own on the road, so you don't need a human intervention or such. Of course there is a person sitting inside the car, but that is actually he's training the car to identify those objects to see that whether is everything is working. But on the driver's seat there is no one. uh, so even the AI in creative industry, like you can use your machine learning algorithms or a deep learning algorithm to create your own music, write your own novels. Right, if you see on your left hand side, it's called Sonnet 1, which is actually written by human. And the Sonnet 2, actually this is a completely which is written by a machine altogether. So you just have to give few texts, and then it automatically, based on the text and all the um, relationships within those texts, it actually generates your own new set of novels or create music, which can actually, if you see that even the accuracy is close to 95%, which is really good if you build the model like this, where you don't have to write anything and it automatically creates, and it's actually saves a lot of time too, and more creative. uh, and one more example of AI is like this is amazing, because this is actually used for people with impairment, people who are handicapped. They can use this which is Microsoft has already built it, where you can just go on the road. The people with impairment, they can easily identify things on the road. They can easily, even they have an app which can actually identify how much cash they are paying and how much they are getting it back, who are on the road, whether it's a cat, dog. uh, so of course you can hear with the noise from the animals, but at the same time this is the wonderful thing which Microsoft is building in terms of helping the people with impairment and doing a lot of things to the society. So basically, what is machine learning? So here I thought that first covering what is the difference between the machine learning, deep learning, giving you a few examples of how what all the AI things which are currently evolving, and then I would like to go little bit deeper in terms of machine learning and deep learning, because there are concepts which are actually used in machine learning and deep learning which uh, it's really good to know, or good to have it in mind when you're all working on any projects or anything. So what is machine learning? So it's actually a system that may able to make predictions or take decisions based on the past data. So what actually it does is, like, it does predictions, gives quick and accurate outcomes. How accurate is also actually based on your data as well, because how accurate your data is actually leads to how accurate your model is. And it has more powerful processing capabilities. It can analyze big data, manage large amount of data, and it's inexpensive. And why you say inexpensive? Because the most of the tools which are currently we are using for doing all these problems are open source. So unless and until you want to become a citizen data scientist, what do you mean by citizen data scientist? Where I don't want to code, I don't want to do programming, but I wanted to use already the existing tool, just drag and drop, and then I get an answer. So then it gets expensive. But other until then, this is very inexpensive when compared to using other tools. So what actually deep learning is, like, which actually learns think and learn like a human using the artificial neural network. Of course we also use neural networks in machine learning, but this is something advanced level of neural networks, where we talk about image recognition, identifying the objects on the road, identifying, scanning through the different documents. That's where the deep learning comes into the picture, where it actually one step ahead of what machine learning does. Of course, there are machine learning algorithms which we use inside the deep learning to solve the problem, but it actually solves a much more bigger problem of in the society when compared to machine learning, which is more towards an structured data as such. So what are the advantage of your deep learning, right? It improves the performance, more data, better scalability, right? Problem solved. Currently, we have everything in cloud. We are going to cloud. Industry is going towards already in cloud, and they are. It will expand further. So all these things looks much more easier once you move to cloud, right? Because everything is set it up there. You don't have to do everything manually or create an infrastructure to really do a deep learning kind of work. So everything is just inside. You mean sometimes you don't have to even code. You have an automated ML inside the cloud, where you can just use it and start doing machine learning or deep learning kind of. And it also take lesser time, because the advancement of powerful computers and GPUs and TPUs, uh, the things are much more easier. So in nutshell, what actually machine learning and a deep learning means, right? So machine learning, it's like which enables machine to take better decisions, requires only small amount of training data. Whereas if you go to deep learning, machine it takes helps of artificial neural networks. It needs large amount of training data, of course, because you cannot. Then the model will start to overfit, and then the testing takes longer time, and the testing takes less time when in compared to machine learning and deep learning. The problem is divided into smaller parts, and then it's all individually, whereas the problem is solved in an end-to-end manner. Okay, so what are the real life examples? We have already seen a few of the Amazon Echo, like artificial intelligence system is this. Machine learning. Even machine learning we are using on a day-to-day basis, but we all know that even a Gmail, right? So how do you think that the emails are classified into spam and non-spam? So there is a machine learning algorithm which is running at the back end, which actually scans through your email, and then of course there are sometimes it actually scans your correct email actually into also in spam, but that is always an error rate which is acceptable. But most of the time it actually classifies your email into an spam and non-spam email. Uh, and then the deep learning, where we talk about Alexa or Siri. It can actually, on your right hand side, if you see, it actually scans through some particular product and say that exit. So it's actually exiting the particular website. It scans through all the product. On your left hand side, it's a chatbot. It's also a application of a deep learning. We talked about chatbot, everybody knows that. So what actually the life cycle looks for in machine learning? We have already seen before about the data science process, like how do you start with understanding the problem, acquiring the data. It's similar. It's similar to that, but this is where we talk about model deployment. So deployment in a very simple sentence is nothing but how I'm going to make this model to be used by the end user. Right, so that's where we talk about deployment. So it starts with a business problem. It can be an image, text, audio, or you can say machine learning slash deep learning lifecycle. All right, and then problem, we formulate the problem, whether it's a machine learning problem or it's a deep learning problem. Then the data processing occur, which takes a lot of time compared to building your model, because there are already pre-trained model which are available in Google, which you can use it to build the model. But the most of the time which is spent is on data pre-processing. So 70% of the time, I should say that it starts with business problem, problem formulation and data processing, and then all this algorithm. Remaining 30% is, I would say, that divided among algorithm deployment and retraining. So it starts with the data processing, and then the algorithm is built, then the model evaluation is done, whether it's a model which can be used by everyone. So finally it comes to a question that whether it meets the business goal. If it says no, then again we go back and do the data pre-processing to really see that whether we have done all these steps correctly, whether we need to introduce few more variables, whether we have to pre-process the data. And if it meets the business goal, then we go for deployment in the sense where we talk deploy the model to the end user. But the job is not done yet, because deployment is not the end goal. Sometimes what happens that this may work for 6 months, and suddenly, like you have seen that COVID has come, right? So the business has impacted, so the entire model will change. Because the reason is, first 6 months of data which we built, the model was steady time, right, where there were no turbulence and everything. But after next 6 months were really difficult, where we had a COVID, we didn't go to office, there were no productions, nothing. And now we have to integrate all these factors into our model. That's what we call it as new data or retraining. And then again we go back and do the same step again of data pre-processing and everything. And then it goes through the algorithm model building, and then again further stay. So, and then even in the non-COVID situation, not every time you get that same data again and again, right? After 6 months of, after 1 month of you working in an industry, suddenly you want, somebody says that I want this product, right? And this product is comprises of all your machine learning or deep learning algorithms, which is actually an AI product. But what happened is, like last 6 months, your industry or your company has gone through the transformation. So there were several factors which are missing when you build the model. So these factors were missing. So now what we have to do is that reintegrate and bring those data into the model. And again we have to start from the scratch, because the system is already built, so you don't have to do everything from the scratch of identifying the business problem or formulating the problem. So this is how the entire process goes through. uh, this is the overall process. There is no change generally we see in the industry whenever we are executing any machine learning problem or a deep learning problem. This is the end to end picture. So what, now we have heard about machine learning, we have heard about deep learning. I have already talked about what are the different business intelligence tools, reporting, predictive modeling, what are the examples we have used. So it doesn't end here, because we really need to understand what are the different types of machine learning we have, right? So there are three types. One is the supervised learning, unsupervised learning, and reinforcement learning, which is these are all things which actually leads to your AI product. So it's very important that we understand what is supervised, unsupervised, and reinforcement learning. Supervised learning is like where we have a well-defined goal. So we have an outcome For example, fraud and non-fraud transactions, churn, people no churn, right? So this is where you have an end outcome is already fixed. Unsupervised learning, where we talk about the outcome is not at all fixed, and you do like clustering, segmentation, where you try to find the pattern on their own based on that. And the reinforcement learning is something which is currently used in the industry quite a lot, because this is more powerful, where there is a start state and an end state. So it's I will explain in very simple manner, like what actually these three means. This is one of the quick example, like supervised, where you have focused outcomes, unsupervised learning, where you have to discover patterns on your own. There is no fixed outcome as such. And reinforcement learning is like where you learn from series of action. Um, Let me give an example with the baby learning about the apple and banana. So first you show baby apple and banana, and baby understands that okay, this is the shape and possibly a different color altogether, but this could be an apple, or this could be a banana. So this is a supervised learning where you know the outcome, the baby knows the outcome, whether it can be an apple or a banana as such. Now in the unsupervised learning, there is no as such, right? So you give a picture to the baby and say identify the dogs and cats. So it goes through all this, it goes to the picture and say, oh, this is, if this is the height, right, then this is a dog. If it has a long mouth, then it's a dog, right? It's a taller, then it's a dog. And if it's shorter, then it's a cat. Then depends on all other characteristics, the baby understand that okay, whether this is a cat or a dog. So here there is no initial outcome or the why which we have given to the baby, but rather we gave this picture to identify it's on its own, like what actually this means. And then this is the reinforcement learning. This classic example is how the child learned to walk. So the first thing is what child does is that it observe people, observe family, and to see that how they are walking, all right, and then it attempt to stand up. Sometimes if the baby falls on, so that means the baby is learning from the mistake, saying that okay, if I do these things, then I will not get up and walk, but rather I will fall down, right? And then learning from its own mistake, it's tried to balance again and then stand up again, right? And then it earns a reward of that it can start walking. And then again the baby thinks that which foot to put forward, and then it actually start walking. So this is a step, but this is an example of a reinforcement learning where actually it get rewards for learning, and it doesn't get reward for when it doesn't learn and start falling. So it learns from both this thing, and it knows that if I take this step, then I will get a reward. So that's how the reinforcement learning. You can even think of a real world example, like how if you do something even in gaming industry, right? When you play some games, if you do this, then you lose point, and then you learn from that, and then you start what you call playing well, and then you identify okay, if I do this, then I will get a reward. So ideally the concept is reinforcement learning. Why I'm talking about reinforcement learning so much is like is future, right? People are already trying to see the lot of benefits of using reinforcement learning in their day-to-day business life, even in the industry. So people are moving from supervised and supervised to now to reinforcement learning. So some real world use cases, this you would have already done in your courses, but just to quickly show you like how your supervised machine learning algorithm is work, like for example, if you like to use a credit card data set and whether to approve or disapprove the loan. All right. So on your left hand side, you can see how the data set will look like and what all the factors which you have. And on your right hand side, it's like you're using supervised learning, where you have to say whether you have to approve the loan or reject the loan. And same in terms of credit card fraud, whether it's a fraud or non-fraud. And this is generally the flow of data and features which happens in the industry when you start working on any problem. Like you have all the credit cards transactions, and then you have how the flow of the data and the features looks like. You have all the inputs, all the features, and then you take this into a model or the mathematical equation in a simple term, and then you finally it comes out with the results like whether it's a fraud or non-fraud. The same thing with when you build a simple linear regression model. This is also a supervised kind of a problem. Now something to and this is also we can say as a supervised, but this is more of an unsupervised, because here you don't have an outcome variable. Rather, you have to use this data to categorize things or the cluster things into a more popular movies or non-popular movies, where you use your clustering algorithms, any one of the clustering algorithm to really identify based on your current situation. You can pick up any algorithms and classify them into a clustering or a non-clustering algorithm. Now unsupervised, one of the example is like where we talk about we don't have any information about who has bought this, whether they are a fraud or non-fraud, but rather we have to go to that level of information where we have to really categorize them into whether they will buy this product or not buy this product. So what we do generally is that we use a lot of their demographic information, their purchase information, and based on their characteristics we try, the model try to cluster them into. On your right hand side you can see how the different blocks have been clustered uh, into a different categories altogether. Now this is how the unsupervised algorithms work. And in case of a reinforcement learning, like I talked about, how do you win, right? A game, you know that if I go through this path, if I go to that path, if I will lose. If I go via this way, I get a reward. And this is how you. So this is a classic example of reinforcement learning. And this is now you might be heard so many times about Tesla manufacturing car, right? So they are using a reinforcement learning in their manufacturing unit. How these cars are manufacturing, how these robots are working, they all using reinforcement learning to really understand that what is the start state and what is the end state, what we do correct, what we do wrong, and then it learns and then it automatically manufacture helps in manufacture. These are all robots, there are no humans as such, but they are all working on the concept of reinforcement learning. And that's what I mentioned, that this is currently what is currently very widely used in industry, and it's good to know and practice more problems around this to understand the application of how reinforcement learning is used in. So this is something which is you have already seen. Like one of the example, like you search for something on the Google and you select one of the first few links and spend time there, and then it records all the information that how much time you have spent on this particular page, right? And the next time when you are going to do a search, it automatically gives you all the information, and then it understands the user what it has, what was required, right? So the search becomes much more narrower when you search again and again, because it tracks all the data which you have used, what page you were in, because there are so many pages when you search for something, right? Which page actually you have um, really went into, what are the things which you have looked at. These are the simple things which actually it captures, and then finally it uses all these machine learning algorithms or deep learning algorithms to actually categorize into a which one you understand, the Google understand the users rather. Uh, yeah, and this is very common. This I wanted to show you this examples how the AI or the machine learning is currently used. We all know this. Um, like example, Amazon, right? On your left hand side, if you see the ranking, recommendation, classification, regression, clustering, anomaly detection, all these things are done with within Amazon, right? And how they do it is very classic. That's at the back end, but in the front end we all know, right? So if you say ranking, so it actually helps user in finding the most relevant thing, right? Again, it's using a machine learning algorithms there. So now what kind of product we should recommend to people? All right. So that's also it. Actually, it recommends. Right? These are the products which has to be recommended. So where we build a recommendation engine at the back end, it also does the classification. Right. what kind of dresses we would like to. All these things are already there, but what we are using at the back end is all this machine learning and deep learning algorithm. The same thing we can be used for any other industry as such, right? It's not only applied to the e-commerce industry, but it also applies to any other industry where we can work on all these problems like ranking, recommendation, classic, regression, right? So it actually helps you in predicting and value for a particular thing. What will be the value for this particular necklace, right? How many people are buying it? What is the cost of the cost of this each and every product which people are buying? And it also takes into consideration your seasonality, out of stock, promotions. So if you see that this all things are considered, and then it's also predicts you like, okay, what will be the price of that, because we will be thinking how Amazon particularly price this particular product, right? How this price for a particular product is defined as $20 or $30 or 500 rupees, right? So it actually uses the ML or the time series or a simple regression to take care of all the seasonality, out of stock, promotions, user behavior, how many product has been purchased, and what should be the value for this particular product. Again, clustering. So you have some you are given some preferences, and it actually clusters according to your price, your need, your brand, and your kind of a shirt. It actually clustered everything into what you're looking for with similar characteristics. That's the basic cluster things with similar characteristics. That's what is currently Amazon is also doing there. Anomaly detection, right? So you have so much product. What do you mean by anomaly detection is like identifying the bad product or a good product. So it actually before how was the product, and after how was the product, right? And it takes the product into consideration and then classify into good, and because this is very important for especially in terms of e-commerce, because you don't like to get something which is bad. You like to get something really fresh. All right, so Amazon uses all this things to machine learning algorithms or the problem to solve their entire actually the e-commerce thing. And okay, this is for most of a machine learning algorithm. Next, the deep learning is solving much more difficult problem, especially speech recognition, image recognition, and natural language processing. So you might be knowing that how Siri and Alexa works and how the self-driving car works, and they use all natural language processing to now they have come up with like natural language understanding, where you given a context you automatically, because I don't have to generate a document altogether, right? I have to really say that, okay, fine, this is the sample report, and I need to really generate these kind of reports in future. I don't have to manually uh, type in the Word document that this is the particular report for this month, the next month, the next month. Now once you have this already natural language processing, you actually feed those reports which you have already built, and it automatically start typing, and then it automatically creates many reports for you, so it saves a lot of time. And then you can go and cross verify whether those reports are how accurate they were. But so far it's been very promising. And this is one of the example, like you have different color black and white image, and you use don't go by the convolutional neural network, because that is a kind of a neural networks for doing most of an image recognition problem. This is part of a deep learning where you convert all your black and white image into a fully colored image. So what actually happens, how it happens, because that is much more important to understand rather than that it does this, right? So initially you have a on your bottom you can see initially you have black and white image. It searched through the websites and the data source which were available, right? It understand that what kind of a color actually these balls were, they're available in the website in the repositories, and then automatically mapping a particular color to an object, and then it makes it fully colored. So that's how the things happens in a deep learning. It's not about just you provide an algorithm and it convert into colored image, but what actually it does is that it search through the databases, repositories, and everything, and see what kind of similar colors and for available for the ball, and then it starts mapping those colors and then finally converting them into a fully colored image. So now I'm coming to the most final part of it, where we have seen machine learning, deep learning application of machine learning and deep learning, how the AI is finally coming as one product by using all these algorithms, how different industries are using, especially Amazon, it's using all this different business problem to solve their entire e-commerce problem as such, finding anomaly detection, predicting the value of a particular product, clustering. But all these are good, everything is good, but we should know when to use AI and ML. We cannot use because everybody is using it, right? We should really know when this actually makes more sense, right? If you see on your the quadrant, like you have in your x-axis, like a problem complexity and frequency. If you remember, I showed initially one of the graph, which the spectrum of data science, which actually on your x-axis you have your business complexity and business value, and on your y-axis it's the complexity. So the more the business value is, more the complexity, then you go for artificial intelligence. The similar kind of a thing here as well, where we talk about the problem complexity altogether. So if you have low complexity and low frequency, then human can solve it. So you don't need a machine to solve it, right? And if the complexity is low, and then if you have your frequency is high, then you can build a dashboard on your left top corner. um, and if your complexity is high and your frequency is also high, we should go for something deep learning like Apple Siri, Windows Cortana, Google Now, etc. Right? So depending on the complexity of the problem and the frequency of the problem, we should actually go for what kind of problem. So when somebody gets inside the industry, start working on any business problem, these are the things which we one should ask first. All right, not jumping into any as soon as I get the data, okay, I have a business problem, I will solve it. And first of all, what's the value it's generating? If there is no value which is coming out of the product which you are building, then there is no point in actually building any product at all, because that's what is said in the industry. If it's not going to add value, then there is no point in building that. So first of all, when I start my day at office, and I want to work on a problem, first I understand the problem and put my problem into this four quadrant, and see whether what actually I wanted to build. All right, what I am trying to build. If it's ML I can solve the problem, then I will use an Excel. But if it requires really it's a complex problem and the frequency is very high, then I will go on building an AI and ML product. Otherwise, a simple statistical modeling can also solve my problems, and that's how it works. It's not necessary that we should always use machine learning or deep learning to solve any problem, unless and until it's really required. So, what are the pros and cons of AI and ML? Because people always talk the rosy things that we will use machine learning, we will use deep learning, we'll build an AI product, but there is a complexity involved. It's categorized into four different types. One is interpretability, right? Today I build a model, right, and I built a product, right? Somebody comes back to me and asks me, okay, you have built the product. I would like to know what algorithms you have used, and I would like to understand how it can interpret. If you cannot interpret what you have built, then it's of no use. You should be in a position to interpret it really well, right? So if you see on your top the columns which are based on rule based, statistical models, machine learning and deep learning, the interpretability is more high for the rule based, which is, even you can say, a decision tree, which can actually helps you in identifying path. But if you go higher, deep learning models, the interpretability is very less, because it's highly complex. You cannot really go deep inside that and to make people understand what actually says. So very key is interpretability. If I cannot interpret, then what I built is of no use. Then the accuracy of the model, right? So it has a both positive and negative side. If you see, the accuracy of the model is more high for deep learning when compared to all other thing, but it comes with a cost and execution to implementation, right? Rule based is much more easier, right, faster to implement, but deep learning, it requires a lot of infrastructure. But coming to the cloud and everything, but it comes with a cost and resource required for implementation. If you see, deep learning is high, right? Because that is, you have all the infrastructure currently available. So these are the 4 points which we really need to consider when we build any kind of a model, AI and rule-based or statistical model or machine learning or a deep learning model. We should be thinking all this. We should think about this first, see whether it's going to generate value. Once it says it generate value, then what I'm going to use it for. If it's somebody is talking about, for me, the customer says, for me interpretability is very important, right? So that time I will say that, okay, fine, I will not go for any deep learning, I will even stick with statistical models, right? For me, accuracy is not that important, right? Then I can stick with rule based. But if somebody says, no, I want more accuracy, I don't care about interpretability, then we should talk about deep learning, where we say that, okay, we build a product which the accuracy is so high. So these are the things which is we have to keep it in mind when building any AI related product. So what are the recent AI development? So actually, if you see that this is there for last 50 years, right? So why this AI and ML is getting so much attention now? Um, because three things. One is data generation, storage cost, and computational power. In past, we have algorithm, data, computing power, open source tool, right? But we don't have a compute power that was missing. All right, now we talk about graphical processing unit, we talk about tensor processing unit, we talk about much more higher, right? So one of the reason why this AI and ML is getting more attention is because of the compute power, and more of an open source tool, all right? Because earlier there were only standard tool like SPSS, Minitab, MATLAB, right? You can't do everything, but now there are so many open source tool which can be really leveraged for solving all this problem. And now with the computational power, it is much more. And again, one more thing is the data generation. If you see how the data has been generated in 2020, if you see uh, um, in terms of connected vehicles and in terms of the data generation, it's so high compared to the days where we started from 2012. How things are connected all together, and we can get so much of data to solve any problem. Storage cost, right? Now people are talking about, initially there was some big hard drives like they used to bring in a trolley. Now you have everything in the form of a chip, right? Where you can save all this data. So storage costs also gone down, but in terms of the size of the hard drive, and the cost of computation continues to fall, and it will fall because everybody is using it, everybody would like to use it, everybody wants to see data science, AI to happen in their own industry and company. So the computation will continue to fall. So what are the building blocks of an AI system? We have already seen machine learning and deep learning or the backbone of an AI system, but what all the generally the building blocks? So it's nothing but the input, but actually the you capture all the data from, right? The data is captured from the user, atmosphere. If you want to do something related to climate, then it's also captured from camera, mic, etc. So once this is done, then you have processing and storage, which we talk about edge. Edge is all about in your own computer, even you don't need internet to do it. And the next is your cloud, which I was keep talking about, like everything in processing and storage. So you don't have to do anything, everything for you is in cloud. Your company pays for it, and then you have to just use their services to solve the problem. And the final is your output or interaction, like how this is where I talk about the deployment, where how do you like someone to use your product, which you where you have used your machine learning and deep learning to build it, right? So output can be either in the form of a voice or a robotic action, right? So the robot moves hands here and there and it picks up something for you, it's in the Tesla manufacturing units trying to assemble the car, but at the back end you have provided all your deep learning or machine learning algorithm to it. So the front end product or is your robot. So now, yeah, self-driving car, which I already talked about. So now the next thing which I would like to cover is what are the data capturing types and tools. So we talking about big data, we talking about volume, variety, and veracity. So, but when we need actually to use this big data tool, right? So if I have a 5 GB of data, do I need really big data tool? Not required, right? Suppose you have somebody asks you to analyze the data, and if it's just 5 GB of data, you don't need. to use a big data tool to solve the problem, right? But if you have 50 GB of data, of course, you will start using big data tool, right? Now it goes behind that 100 GB or 1 TB of data, then you need a big data solution, all right? You don't, it's much more bigger, means you need a much more bigger infrastructure to hold all these things. Of course, coming back to the cloud and everything, which can handle on things on its own. But these are the things which is actually required for you don't have to use everything big data for everything. First you have to really analyze that, okay, what is the kind of data which I have, whether it's a small data, it's a big data in terms of volume, right, variety and velocity. Now what all the tools which you can use it, right? If you have 10 GB of data, you can go for Excel, Microsoft Access, right? But if you, as soon as you move to the higher stage, you start using SQL, Hadoop, Hive, right? So these are don't get carried away by this, but maybe you would have already know about this. These are nothing but the big data tools, right? Hadoop is very quite frequent, widely spoken about, and then Hive. So these are the things which can use it for storing the data. So variety. So there are, we talked about three things, right? On your left hand side, volume, variety, and velocity. So we covered volume, like if you have this much amount of data, then what all the things which you have to use, what are the tools which you can use, and if you have higher level of data, you can use these tools. Now the next comes the variety. So there are different types of data. So we talked about initially when I started, like structured data and unstructured data, because data science is nothing but a system which extract, manipulates, build algorithms based on structured and unstructured data, right? There's a structured data is like we have tabular data, employee table, loan application table, etc. Unstructured data, we have email, text data, social media, customer feedback, video feed, satellite image feed. So these are unstructured data. So big data is nothing but comprising of volume. We all talks about volume, variety and velocity, and this is also right. So how do you store, right? SQL is more for a relational database. SQL we use for querying the database to extract the information, and not only SQL, which is we called as NoSQL, which is more for an unstructured kind of a data. Like when we talk about unstructured, we have social media, customer feedback, video feed. These are all unstructured data. To store those kind of data, we also need NoSQL. People are now talking about PostgreSQL. So these are the different things which we really need to know when we start working in an industry. Uh, at least basics of this to really understand, if you to understand if you want to become a data scientist or a data engineer or as such. And then the velocity, right? The speed at data which is being captured in real time. So we have sensor data, we have data coming from self-driving car, we have CCTV data, we have stock trading data. These are all live data. Which is why live? Because it happens every minute, every seconds, and every hour, right? So these are the live. So you have to have a tool which actually takes care of your volume, variety, and velocity, right? And then in terms of if you have velocity, I talked about sensor data, self-driving car data, CCTV data, or stock trading data. So if you want to store this kind of information, then you go for further bigger end, like Kafka. Don't go by the terminologies because you can learn on your learn over the period of time. But these are the things which are actually available in the market to really understand that what kind of tool I should use when I have this kind of a situation, right? You cannot use everything for one thing for everything, right? It's not a one solution problem. And then what are the common tools which are currently used in the industry? For visualization, Excel is quite old now. People are talking about ClickView, Tableau, Power BI, MicroStrategy, Google Analytics. That's the future, right? Because we are talking about cloud, and Microsoft is Power BI is Microsoft product, right? And Microsoft has already come up with cloud. It has Azure cloud. So they have already all this product in built in. So when you think of building any solution or AI solutions inside any industry, you should think of a complete life cycle, starting from the spectrum of data science, which I explained, like from reporting to the building the AI product. So one should understand that what kind of tools which we really need to use, which can be used end to end. If you use Microsoft product. Like you have Microsoft Excel, you have Power BI, then you have Microsoft's own Azure cloud, then inside the cloud you have SQL, you have all of the databases which can actually completely use as one product and delivered as one product, right? So you can use Microsoft for entire thing. So which has all the product for visualization till the final reporting. Now the predictive analytics, Python, R, Spark, Julia. Now Julia is in competition with Python, is almost coming there. But Python is the thing which is big. The reason behind is like for deployment on cloud, or final end product, Python is very flexible. It's very simple to learn. It's very easy to learn rather. And R is also picking up, but the scalability in terms of if you want to do a bigger projects and all, the in cloud and other stuffs, Python is very well supported. Then you have Spark, then you have MATLAB. SPSS is okay, it's quite little old. And now SAS has come up with something called Via, which is very expensive, but actually that is also can be used for building models, which can be a drag and drop. Yeah, so one thing which I always talked about, like how what is mean by GPU and TPU, right? So you, for if you want to perform something in deep learning where you want to do an not everybody would like to do self-driving car, but deep learning has its own several applications, right? So if you wanted to have high computational resource, utilize this resource effectively, then you should go for GPU, which is nothing but graphical processing unit. And then you have a tensor processing which is much more advanced, right? So in an industry, when you get inside, people will always talk about GPUs and TPUs, and these are the ones which is actually help you in doing the computational work very fast. And then what are the different frameworks for deep learning? Like we spoke about predictive analytics, right? Like for this, the same for deep learning, there are different frameworks which is currently used in the industry, which is like TensorFlow, PyTorch, and Keras. Everything is Python based. These are the things which, these are the libraries which actually you should use to build any deep learning models. TensorFlow is by Google, right? PyTorch is something separate, and I think PyTorch is from Facebook. Not sure, but these are the thing which you will use, and with your Python language, you build all your deep learning kind of solve all deep learning problems. And Keras is very beautiful because it is built on top of TensorFlow, and this is also very important library for building. Like in R, you have different packages like Caret, etc., etc., etc. So like this, in in Python, you have for solving deep learning problems, you can use TensorFlow, Keras, and PyTorch. And these are the AI tools, which is nothing but AutoKeras, Data Robot, H2O.ai. Sometimes back you should also explore about H2O.ai because currently it's widely used. And then you have Amazon Lex, Google Cloud Platform. So these are the kind of which has AI tool in between inbuilt. Data Robot is a separate product like SPSS, where you have to just uh, select and drag and drop, and then it works. Most importantly, when you are using all these tools, right? So you in industry, you work not, sometimes if you work individually it's okay, but when you work, you mostly work as a collaborative, right? So when you work collaboratively, so what happens is like you write your Python codes and everything, and you would like to share with your team members for review. This is how it happens in the industry as of now. So if you write your code, it has to go for peer review. Your peer has to review. So how will you share, right? You cannot send it in email or a Word document that please review and send, because it has to be synced, right? So we write code, and then finally we also share it with our peers using a GitLab, right? GitHub is also where you can showcase your activities in terms of if you're learning new projects, if you're, for example, apart from your college or industry projects, if you practice something separately where you wanted to showcase to your future company that in your CV, that what you have done on your own, uh, then you can use GitHub, right? Where you take a data set from the website, you build your own model using Python or R, not R, Python, and then post it in the GitHub. And when you go and present it to your new company or employer, you can put it in your CV using this GitHub link. If they click on this link, they will go to your page where they can see what the work you have done, right? So this is a very good way of showcasing your work, apart from, and this is also used in industry on a day-to-day basis. Like whatever the code I write, somebody has to review it, so they have to just, they pull my code from this particular repository, they review it, and they send it back to me, and then finally it's sent for deployment. So this is very important thing which is currently widely used in the industry. And what are the skills requirement? Basically problem formulation and communication. For extraction, you should know SQL, Python, R. For data exploration and building data stories, you need BI tools, Tableau, Power BI, statistics. And for predictive and forecasting modeling, you should need structured data understanding, unstructured data understanding, like deep learning, computer vision, natural language processing. And finally, model interpretability. So there are a lot of new things which have already come in to this world in terms of in the field of data science, where actually you can interpret the model, right? It's not about just uh, when you build a model, it can actually show you top 10 importance based on the value coefficients, and at the same time, it actually, there is a tool called Lime which can actually build a model and showcase in such a way that anybody can read it. So it's a very, very simple. So the model interpretability has become very less. If you would have remembered that I have shown that what is important is not about building a AI model. What is important is how interpretable it is. Otherwise it's of no use to anyone. So these are the skills required. So where to start? It's, you can go for Kaggle, right? Kaggle, everybody knows that this is one of the platform where you should go and pick up any data set and start solving, and to showcase your work, right? Um, and then you can also look at this like CS231 Stanford UDS. It's lectures by Stanford for understanding the deep learning. It's a very nice lectures. So if you get time, you should read about those lectures, the mathematics behind it, and understand that how can be applied in industry. And then there is fast.ai. And if you want to really improve your Python coding, then you should enroll for hackerrank.com, where there are a lot of problems starting from simple to the advanced problem is being solved, right? You can pick up those problem working on your computer and showcase to someone using GitHub, right? That these are the things which you have already tried. So this way you can improve your Python skills. And if you go to the Kaggle, use these Python or R skills to solve the problem in the Kaggle. Pick up any problem and start solving it. So generally, it's not about AI. It's all about how do you solve a problem, from irrespective of whether it's a machine learning problem or a deep learning problem. But this is how the future. This is how the steps are towards to build an AI product. And the future is like, it's already there. Like people are talking about detecting crimes before they happen, humanoid AI helpers. And what is problem with machine learning? Increased efficiency in healthcare, better marketing techniques, deep learning, increased personalization like you have it in Amazon, personal assistant like chatbot, which is already there. So what I will end up with my talk with what are the current AI problems which we are trying to solve across the world. You all know the biggest problem is climate, right? So because the ultimate goal is to create an open source of worst polluted areas in the world, right? Once these places are located, the process to clean such areas can be initiated. All right. So this is one of the biggest problem which currently the people are working on, to see that how we can identify the worst polluted areas in the world. Uh, Epidemics, we have already seen one of them, which is already currently. So can we predict well in advance? It's still a question that. And the third thing is efficient energy consumption, because you all know that by 2050 we all going to be moved to electric, right? So all the fossil fuels which have been already been destroyed so much, it's the biggest problem. and which we can't recreate, but rather whatever is currently is there, we can really make it stable. So it's the goal is that by 2050 it should be all electric. So people have already started towards effective energy consumptions with AI. So this is the problem which currently people are working on with AI. Another bigger problem currently is preventing the global food crisis. This is another big problem in terms of what people are solving in terms of artificial intelligence, because this is very important to reduce malnutrition. And last and final, I think it's going to accurate medical diagnosis, which is big problem across the world. That so if you really like to say, okay, what all people are working on currently, bigger problem for the world, how can we support the society, you can actually go to any one of these and I think start supporting in some or the other way to make sure that uh, most of the things are covered. So this is not about that only certain people will solve, but I think if you just google it and find these things where actually these things are happening, you can really go and support them, and then you can showcase these works as well to others, that this is how so with this I would like to conclude my talk. So
Thank you, Pradeep.
thank you,
Now
Deepak.
we are open to questions from the audience. We'll take Pradeep. We'll take one or two questions from the audience if they have.
Yeah, sure, please.
Okay. Only thing is, I request you all to tell your name first and then ask the question. And also, please mute the audio after you have asked the question. Thank you. If there are any questions, please go ahead. And if you are not, then at least you can put it in the chat box so that I can read it.
Or please feel free to give your feedback as well. So that's also fine. If you don't have any
Okay.
questions.
Hello, this is Kavya
Hi.
here. Good morning.
Hi, Kavya.
Yeah. So my question is like, how far this data science programs like courses are really, can be utilized and it is effective enough, to start from the scratch. And if there are some of the courses as such, can you just suggest like which is the starting point from which we can just take the things forward? Because see, being a coming from a non-engineering background, basically, for almost all the it could be academicians or it could be industry, who people who are willing to get into industry, but we have statistical knowledge. So basically, I'm not an engineer. I've completed my MBA and PhD also. But since even in academics nowadays, we teach a lot of marketing analytics, HR analytics, and a lot of application of predictive analytics, even in management, to be very specific. So, to go to the next level, when we also have to gain some more insights and knowledge, so to take up any courses, is there anything like that, like we can just take up and we can get very good outcome out of it?
Yes, exactly. Thanks, Kavya, for this question. It's all actually depends on. See, I will answer in two ways. Maybe it answers your questions, and if not, please let me know. Sorry. The one thing is that the courses, the classes, and everything are good, right? But it's all comes with your own self effort, right? Because if you have passion for this, if you have to put more effort when compared to your courses, because courses will teach you, okay, do this, but when you come to the industry, it's completely different problem altogether which you will face.
Exactly.
Right. Right. So but the tools and techniques which they will teach you, you will use it, but the problem may not be the same, right? So for that, you have to really start looking at the data set which is already available. What kind of problem would you like to solve? There are a lot of open, like I mentioned about Kaggle, right? If you go to Kaggle, there are people who have already posted, people who are already solving a lot of problems there, different kind of problems, even the industry problems, right? So you'll get a flavor of how the problems looks like, right? And then use the tools and technology which the courses teach you, right, to solve those problems, right? So when you solve more problems, you will get that confident. It's not about solving the problem. It's all about what type of problems, right? One is a structured problem, which is you have very tabular data, which you solve it. And there are unstructured data like text data, text mining, sentiment analysis. These are different types of data. So which is already available in Kaggle or open source, which you can use it to leverage.
Right.
If you come
Sure.
to the industry, definitely you will solve any one of this type of problem, not this problem, but any one of this type of problem. So you already know how to handle the structured data, right? And you already know how to handle an unstructured data. So
Right.
come to the industry and you will get a new this kind of data, and you say, oh, I know this type of problem, but not the exact problem. You'll never solve the exact problem which is taught in the courses or anything. At the same time, there is second thing is like, if you don't want to code or anything, there are citizen data scientist tools available. What do you mean by citizen? That where it is a drag and drop, and you have to use your brain to solve the problem programmatically, but you don't have to write any code there. All right. So that also helps you in solving the problem. So if you are not comfortable with programming, you can go for these tools,
Okay.
which can, yeah.
Orange is one such a kind of tool, if I'm not wrong.
Yeah. Orange. There are Alteryx, which is one of the tool which is currently used in the industry very high, because this is also a drag and drop tool. You can do everything there. Everything.
I didn't
Even
get
deep learning.
What are these tools known as? Sorry, I didn't get it.
Alteryx.
No. The group of all these types of codes. Citizen code, something.
Citizen data scientist tool.
Citizen data. Oh, okay. Fine. Thank you so much.
No problem. Always welcome. Thanks.
Pradeep, we have few other questions also. One question is from student Sumuk. He says the data is easily accessible, but won't there be any misuse of data and thereby privacy will not be violated or not?
Okay. Thanks, Sumuk, for this question. This is already being handled currently in the industry. We have when we are talking about rules and regulation, there is still some problems related to privacy, but these things are already discussed now initially before we start solving any problem. There are legal and compliance team which actually takes care of this. So, and there is a cyber security team. So when we start solving any problem which requires pulling a data from Twitter or any other websites, we first consult the cyber security team and legal compliance team to make sure that we are not violating any one of the rules. And if we are talking about the cloud infrastructure, people are already on-premise cloud and public cloud and private cloud, where private cloud is like your own company's infrastructure and everything, right? Public cloud is like it's open to all. So there also it's privacy is maintained. So people are solving that problem, because otherwise you cannot use the data and you cannot make any inference. But this is also an harm to the company, but currently it's been taken care of. So in a non-cloud company, usually it's discussed with cybersecurity and legal and compliance team. And if it's cloud, then we talk about more of a private cloud, where it's an on-premise deployed cloud infrastructure where only this company can use it. So there is one. So hope your question is answered, Sumuk, right?
Sumuk, yeah. And last question is, there is one question by Vani Haridasan.
Yeah.
Can you throw some light on prescriptive analytics?
Yeah. So prescriptive analytics is what comes at the end, where instead of you you're doing a basic descriptive analytics. So it's all divided into three types: one is descriptive, predictive, and prescriptive, right? So descriptive is like what you're giving a basic information about the data with some graphs, and predictive is like what you're going to predict about. Prescriptive is like how you're going to prescribe a solution, right? So this is also taking a center stage now in the industry. Before something happens, how you're going to tell them that what all other things which we can do, right? You go and prescribe something. It's simply like if in a doctor, he prescribes medicines for you. It's the same concepts like people are now talking about prescriptive. So that comes at the final stage where you give recommendations and you say that, okay, tomorrow this may happen and this. So it's again a different field altogether to talk.
Okay. So sorry guys, due to limitation of time, we'll not be taking any more questions now. So it's my honor and privilege to propose vote of thanks. So on behalf of the Institute, faculty members, students, I take this opportunity to thank our today's keynote speaker, Mr. Srinivas Pradeep, who was kind enough to accept our invitation and spend his valuable time today. And also, I would like to thank our principal, our head of the department, Dr. KG Hemlata, for their constant support and encouragement to think big. So I like to thank all the faculty members and students for participating in this event. Thank you all, and request you all to attend our upcoming sessions also during our 10 days AI Conclave 2020. So thank you very much.
Thank you, Pradeep. Thank you very much.
Thank
Wonderful
you, Dr.
presentation.
Thank you,
Yeah.
Dr. Deepak. Thanks,
Yeah.
members. Thanks for this opportunity to present. Hope it was useful for everyone.
Yeah, I think it has
Please.
covered comprehensively, Pradeep. I think the
Yep.
thing is, like, students have to put their mind inside and deeply dive into it. Otherwise, you have covered everything, including
Sure.
that whatever I asked you, the data set, where will they get it? You know, good information like Google, all this informations. Maybe
Sure.
anything left over, maybe you can cover on Sunday at the
Okay,
time
sure.
of Alterix. So the students will be ready with few questions. Maybe if
Sure,
they have some
definitely.
points. Yeah.
Thank you so much.
Thank you
Thanks.
very
Please
much.
do let me
Thank
know
you,
your
Pradeep.
feedback,
Sure.
and then I would like to improve as well. Thank you very much.
Thank you, participants.
Thank you, everyone. Good luck. Thank you.
Good luck.